Hello everyone, welcome. Today we'll be looking at another possible NECO question. The other time we were able to look at how to calculate the volume of carbon 4 oxide liberated and also the concentration as well as the mass of the carbonate involved in the chemical reaction. In this second phase of it, we are going to also look at how we can, calculate the relative molecular mass of this compound and also the relative atomic mass X that we have there. So these are the possible questions I have gone through, and I've come to realize that there's possibility that one can see something like this in that exam. So here is a question that we have here, and then these are the questions, the question that you are expected to answer, the instruction and everything. In fact, let's go through it together so that the solution of A is a solution of tetraoxosulphate acid containing 3.9 grams of the acid per dm cube of solution. Solution B was prepared by dissolving 3.6 grams of a carbonate, which is this one we have here, X subscript 2 C O subscript 3. Then in 1 mole per dm cube of 1 dm cube of solution, so that put A into the burette, titrate with 20 or 25 portion of B using methyl orange as an indicator. Record the volume of your pipette, tabulate your burette reading and all the rest of them, so that from the information given, calculate the concentration of A in mole per dm cube, concentration of the carbonate in mole per dm cube, and then relative molecular mass of the carbonates, and also finally we have the relative atomic mass of the S. This is the equation of the reaction, and I will encourage you to stay, don't run away, just relax and be patient enough to go through this as you work it together in order to achieve the same goal. Now this is our burette reading, the outcome of the titration itself. So if you look at the reading, you find out that it seems that the two last ones seem to be the same. So what we do now is, instead of taking all, we can decide to choose the one that are closely uh, um, related. That means they are consistent. The consistent area here, we can use it, which will likely to give us the best results. But looking at this very well, looking at the range, you can as well use all, but I prefer using the one that is close to each other and or consistent to using everything we have here. So in this case now, we're going to, the question said that we should calculate the average volume of um, A used or the acid. So to do that, we're going to take up the average. We're going to take the average volume of A used is then 21.3 plus 21.3 all over 2. When we cancel that, we have the mean of the whole thing is the same thing as 21.3. So the next one we're going to do here is so that we should calculate the concentration of A in mole per dm cube. Concentration of A in mole per dm cube. So what we have as our mass concentration of A is mass conc of A is 3.92 grams, then the relative molecular mass of A is also that when you add up the whole thing, that it will have it to be 98, and then that is to get this 98 means hydrogen, which is 1, and then we have 2 hydrogen. They will say that 2 brackets, that is 2 times 1 plus sulfur, which is 32. We say 32 plus this other one 4 oxygen, and oxygen is 16. When you multiply through, you have this value. So to get the mole concentration of this, what we do now is to divide. If we divide 3 point, remember we said that mole is equal to mass over what? Mm, or relative atomic mass, as the case may be. And relative molecular mass, you can put the relative molecular mass. Then what we have is what? Over 98. Then the value, what we get there will be, we'll get equal to approximately 0.04 mole per dm cube. That is what we have. So the next question there is that we should calculate the mole concentration in mole per dm cube of the carbonate. So to do that now, we are going to use our relation. So we are going to use where our dCA is equal to 0.04 and the volume is equal to volume of the A or the acid. Concentration of this is what we don't know, the base. We don't know the concentration, so times the volume, which we know, and the A and B is 1:1. So we say this was equal to 1/1. That's the mole ratio. When we divide through, so that is what we have. So when we divide through, if we divide through now, what we have will be this crossing over, we will have CB is equal to 0.0 times 21.3 all over 25. So what we have here should be 0.034 mole per dm cube. 0.034 mole per dm cube. That's what we have. So the next one they say we should calculate here is the relative molecular mass of the compound. The relative molecular mass. That is the next thing we know that mass of the carbonate, mass concentration of the carbonate mass of carbonate is 3.6 grams. 3.6 grams. And now we have the mole concentration. The mole is equal to 0.034 moles. So now we don't have the relative molecular mass. And then, but we know that mole is equal to mass conc over relative molecular mass. That is, we know about this. So in that case, we have the mole, we have the mass, then we can make the relative molecular mass the subject of the formula in order to get it done. So what we do here, we come over here, we have our mole to be 0.034 equal to mass, which is 3.8 over relative molecular mass. Then we will cross over. What we have will be relative molecular mass will then be, yes, all over 0.034. So that is what we have. If we divide through, we will have 105.9. 105.9. That is what we have approximately. So the next one we're going to do here, we are going to calculate the relative atomic mass of X. The relative atomic mass of X. The relative atomic mass of X will then be relative atomic mass of X. Now we say that this one, this X, because it's 2 times X brackets, carbon is what? 12, and oxygen is equal to 0. So here will give us, the other one will give us 12, here will give us 2x plus. So when we sum up this in, we are likely to have, this will give us, that will give us 0, and we'll get it up, we'll have that. And the next one is x, 2x equals to 105.9. So then we do the other one, taking 60 over, subtracting 60 from both sides, we have so when we subtract 60 from both sides, what we have will be equal to 45.9. So that is equal to 2x, equal to 2x, equal to 2x. 2x is equal to 45.9. So x will be all over 2. That will give us equal to 22.95. That is the relative atomic mass of that. You can even approximate it. Let's say we approximate, we can have something like this to the nearest whole number. That's the our final answer. Thank you so much. And I want you to watch the first of this analysis, volumetric analysis, and then if you have not like, share, and let's hear from you via the comment section. And if you really want to communicate with us directly, you can also go to our description section and visit the Facebook page there. Then you will be able to communicate to us directly. Thank you so much.